Hi, I'm Luke from Dotscience, and I'm going to tell you about our solutions for machine learning model management and why model management is an important problem to solve if you have a data science team. So the industry context here is that every company in every industry, whether they're startups or enterprises, are trying to gain competitive advantage from their data in 2019. It's a technological arms race with companies building models to automate making business decisions. What's more, every company seems to be wasting time building their own data science platform. And even when they have a data science platform in place, you often see teams doing manual tracking, which means that versions of data and code can be easily broken. This is especially painful when team members leave or teams get audited. Dotscience provides a data science engine for you so you don't have to build one, and it provides complete automatic tracking of all the work that's done using that engine. So don't build your own data science engine, come and try Dotscience today. So as I said, gaining competitive advantage from data is top priority for every company in every industry in 2019. So across industries, we hear this all the time. Let's start doing machine learning. Let's start an AI project. Or let's expand our data science team. And in order to do that, these companies are building this engine that takes data scientists to operate the controls, feeds data in at the top, and spits out models to automate business decisions that then get deployed into production. But even with the best will in the world, chaos often rapidly ensues. And one of the reasons for this is that these controls in the data science engine look a little bit like this. Even with one data scientist, the data they're using will change, the version of the code they're using to train their models will change, their libraries will change, the parameters that they use when training the models will change, and so you get this explosion in the number of models. And this is hard enough to cope with when there's just one data scientist, but it gets exponentially harder when you have many data scientists working on models at the same time. So you get this sort of explosion in the number of models and the complexity of all the variables that went into building them. Now, unfortunately, humans, when faced with a problem of tracking things, often turn to spreadsheets. And so we've seen many spreadsheets like this in the real world. You get to see who was doing an experiment, what input data they used, what parameters they tried, what version of the code they were using, and the resulting accuracy of the model they were building. Now, there are clearly some problems with this approach. Firstly, what does big V2 final actually refer to? Who knows? It's probably a file that was on this data scientist's machine. Now, is this a complete set of parameters, or is it just the ones that Bob thought was important when he was doing this training? What exact version of the code does master refer to? Did this data scientist commit the exact version that created this result? And are these accuracy numbers really comparable when they're using different versions of the input data? The answer is no, unfortunately. Now, what's worse is that when data scientists leave, they'll often leave with a lot of knowledge about a model stuck in their head. And even worse, fast forward 6 months, and if this data science team is audited, then this spreadsheet might be the only thing they've got to rely on. So let me show you how Dotscience solves these problems. Dotscience provides a suite of products that help you solve all of the problems I've just described. There's data version control, dashboard, provenance graph, and runners. Data version control captures data, code, parameters, statistics, and environment all in a single commit, which allows you to tie together all of the changes that get made during the model development process. Dashboard allows everyone in your team to see a synchronized view of the work that's been done and collaborate more effectively with each other. So dashboard is about productivity. Provenance graph allows you to answer the question, where did this asset come from? So for a given version of a model that made a decision in production, you can track back to, for example, exactly the data that it was trained on. And runners provides dramatically simplified DevOps for machine learning. This allows data science teams to stop worrying about infrastructure. You can attach any compute from the cloud or existing resources that you have into your Dotscience account and easily schedule work onto them just by pointing and clicking or using our DS run command line tool. Runners solves all of the networking and storage problems about getting the right data to the right place and allowing users to log in securely to, for example, a Jupyter environment in their browser. So now let me show you a demo of Dotscience. So the first demo I'll show you is a house prices demo in Jupyter. I'm just going to drag 2 Jupyter notebooks and 2 data files into this house prices demo. And then I'm going to launch Jupyter just by clicking this button here. And by the way, the runner I've got attached to this account is just a virtual machine that I attached from Google Cloud by running this one Docker run command on the VM. So now we can see in seconds, Jupyter has started up in the browser. And Jupyter is actually running on this VM that I attached from Google Cloud, but you wouldn't know it. As far as the user's concerned, it's just presented to them easily in their browser under their Dotscience login. So I'm going to start by doing some data wrangling. This example is a house prices example, so we're going to predict the price of houses based on various features in the data. So this code reads in one CSV file and another CSV file, and it flags them as input files using this ds.input command. It drops some columns that aren't needed, and then it writes the file out to this combined filtered housing data.csv. So if we run this code, you'll see that Dotscience has automatically picked up that change to the data, and it's made a new commit with metadata about that run in it. So this shows you version control that works with data, code, models, parameters, and metrics. So this is our version control product. As you can see, you didn't have to switch to a terminal and manually commit anything with Git. In fact, everything was versioned automatically just through the use of the Dotscience Python library. So let's go and look at the provenance graph for that data that we just generated. As you can see, provenance graph shows you that this version of this combined filtered housing data file was generated by this run of this code, this notebook, that took as input these two CSV files. And those CSV files, where did they come from? Well, they were both uploaded into the platform. So you can see that with Dotscience, everything is tracked and versioned, and this is incredibly useful for compliance and also just figuring out, like, where did this thing come from? So the second part of the demo is I'm now going to build a model. So if I run all the cells in this model, you can see that I'm taking the output of the previous step as the input for the next step. I can see the relationship between the various features of the data and the price that the house sold for. And then I can see that I'm using just the finished square footage as the feature to build this linear regression model. I'm then training and testing the model, and I'm serializing it out to this linear regressor.pickle file. Now, this error rate is a value that data scientists would care very much about. They want to be able to see, as they change the parameters, how can they make this error rate go up or down? And normally, they would have to track that value manually, either in their heads or on paper or in a shared spreadsheet. But with Dotscience, you can see this continuously updated dashboard of all of the statistics for all of the models that have been trained in the system. So here we can see that run we just did that had a summary statistic of 725k, an error rate of 725k, and you can see on this chart how the error rate varies over time. So let's have a hypothesis that if we add the other features into this linear regressor, that we'll get better performance. Bedrooms, bathrooms, and total rooms were the other features. And so now if I run all the cells, Dotscience will go ahead and push that change up to the hub, from the runner to the hub. And now we can see that indeed, by including more features, our error rate has indeed gone down, which is awesome. But what if you come back 6 months later and you need to see how to reproduce this result? So you can go in and dig into any one of these results. You can see we got this error rate by this version of the code operating on this input data and generating this model. And so we can go in and see the exact code in the notebook, for example. And we can see that this is a finished square footage feature that's being used. And what's more, we can also go and look at the complete provenance graph for that generated model. So this might now be a model that you're running in production, and for this model you can say exactly what data was it trained on, this combined filtered housing data, and not only that, you can say exactly where did that data come from, how was it created. And this is super useful for making your data science process more auditable, reliable, and reproducible. Cool, so that's Dotscience. If you like what you saw, please come to our website and click Try Now. And you can join our pilot program. We can get together on the phone and learn about your use case and then get something working for you. Thanks for watching.